Alright, hi everyone. Today we're going to work on our Algebra 2 final review. I'm going to go through all 24 questions as much as I can. Hopefully I can finish 24 questions by our clock. Alright, so the first question is considering the following graph of the system of equations. What is the solution? Solution means where do these intersect? Where do they share a common point? And this is going to be -1 and +3. That's what this terminology means. So you have to write -1, 3. It's a point, so make sure you do write a parentheses. If not, it will not read it. If you just write -1, 3, I think this is what x equals to -1 and 3. It meets at two places. So I will probably give you partial credit on this though. Me being a nice guy. Now solving system equations here, by graphing, they want you to actually just draw the graphs, okay? So y is equal to mx plus b. Y is equal to mx plus b. So I see that my b value is 2 for my first line, and my slope is -2 over 1, rise over run. So -2 over 1. Right? So I'm going to just leave my dots there for a moment. This is going to auto graph this line for you. The next line is -3. So my b is -3 and my slope is 1/2, rise 1, run 2. And take a look, we already had a point of intersection. That's going to be 2, -2. Okay, so not only do they want you to graph it, but they also want you to tell everyone that the solution is 2, -2. Yeah, easy peasy. That's the solution. Next question is solving the system by graphing. Yay. All right. So we can also solve this by substitution. I think I have a substitution one coming up. So y is equal to -2x minus 2. So this is already set up for us. And -2 over 1. Tell me if you need help graphing lines. -2 over 1. And the second equation is not set up for us. We have two ways of graphing that line. We can either graph the intercepts by making each of these sides into 0, or we can rewrite this as slope-intercept form. 2x plus 4y equals to 4 minus 2x minus 2x. 4y is equal to -2x plus 4. Then we divide both sides by 4. And y is equal to -1/2 x plus 1. -1/2 rise is -1 and run is 2. Rise is -1, run is 2. And then we're probably going to run into each other right here. My line was a little bit off. Up, up, yep, that's it. So it's -2, 2. So this is a kind of a word problem, and it says the graph compares the height of flower A, here's flower A, high flower A, to the height of flower B over the weeks. So as the weeks go by, the flowers are growing. How many weeks after flower A has planted did flower A and B have the same height? So if we got started at 0, how many weeks did it take for flower A to catch up with flower B? 6, 5. That's our point of intersection. But the question is, how many weeks? They only care about weeks. So they just want the 6. Okay, because 6 is weeks and 5 is the inches, is our height. Okay, we're going to solve this next system by substitution. And remember, when we substitute, we try to plug in one variable for the other. And since y is equal to -4x plus 12, I said y is equal to -4x plus 12. So y is equal to -4x minus 12 is equal to -2x minus 8. So this is how we combine our two equations to become one. When 2 become 1 here, and we're going to solve for x. The question is now, which side do I bring the x's to? Now this is Algebra 1 question. I'm going to move it to the side that has more x's. The party, though there's less people here, there's really more than -4. So I add 4x to both sides, and when I do this, that x becomes a positive, which is awesome for me, and that makes my life a little easier. I'm going to add 8 to both sides. 2x is equal to -4. Divide by 2, divide by 2. X is equal to -2. All right, we're at -2, but that doesn't help me answer my question. Well, it actually turns out, x is -2. That's probably my answer, right? Now, just to verify that, once I find x, I need to go back and find y. And guess what? we have two equations that would solve for y. See how it's y equals 2? Just plug in x. So let's take the first equation. Y is equal to negative 4 times negative 2 minus 12. And this is 8 minus 12 is negative 4. So our point is negative 2 comma negative 4. Would this have worked for my second equation? Well, sure. Right? We're saying these lines have a common solution. So if I plug in x is negative 2, y is equal to negative 2 times negative 2 is positive 4. 4 minus 8 is negative 4. Yep. We've gotten the same answer. Darn it. That looks terrible. We've gotten the same answer regardless of which equation you plug it in. And that's one of our points, is that you can get the same solution regardless of which point you plug in. Whoops. I should let Diego in. Okay, here we go. Solve the system equations by substitution. So similar to what we did before, except now there's only one choice that I can plug in. See, y is equal to negative 3x plus 10. So that's the only one I'm going to plug in. Plug that in here. Negative 4x plus, I'm going to put a plus parentheses negative 3x plus 10. That's substitution. We're plugging one guy into the other. And guess what? Instead of having two variables, we only have one variable now. Negative 4x. Since it's a plus, we don't have to, a positive times a negative is a negative 3x. Positive times a negative, positive times positive is a positive 10. And we can combine like terms. And then we get rid of the 10 first, farthest away from x. That's the way I think of it. That becomes 14. Negative 7x equals to negative 14. And then we can divide both sides by negative 7. It's a positive 2. Now, once I know that x is positive 2, we can use the top equation. See, it says y is equal to. It's going to solve for y for us as long as we plug in x. Y is equal to negative 3x plus 10. And that's negative 6 plus 10 is 4. Y is equal to 4. So our point is x is 2, y is 4. All right, I'm already on question number 7. That's awesome. We're going to have plenty of time-ish. So solving system equations here is through elimination. And the first one is level 1. Look, take a look. Don't these guys automatically cancel out? Eliminations when I add down. Sometimes we call this the addition method. So if I add these together, they cancel out, leaving me negative 6y plus 18. If you remember doing this, our equals 18. So we get rid of one of our variables, so we only have to solve for one variable by completing these. Sorry, not by completing, by adding these together. Not a problem, Diego. Sorry about letting you in faster. And we divide both sides by negative 6. So y is equal to 18 divided by 6 is 3. So that's going to be negative 3. But once we solve for y, we still have to solve for x. So you can pick any of these versions you want. I'm going to pick the positive x because that seems to be easier. 4 times negative 3. In case I make a mistake on my negatives. X equals to, oh, darn it. X plus 12 is equal to 10 minus 12 to both sides. Because I'm solving for x. X is equal to negative 2. So we have an answer. X is negative 2 and y is negative 3. The same question goes for number 8. So number 7, we had a pair of x's that canceled out nicely. They were opposite signs and there's the same value. But over here, for number 8, the 5 and the 2 and the 3 and the 4 don't cancel out. So we have to make a choice. Do you want to make the x's match up or you want to make the y's match up? It's up to you. I am going to choose, though, the x's because one's positive, one's negative. So it saves me from changing the sign. Remember, they have to be opposite signs to cancel out. So I'm going to change 5 and 2. A common number I can make 5 and 2 become, I can make them both look like, through multiplication, I can make them both look like 10. So if I multiply the top by 2, 2, 2, and the bottom by 5, 5, 5, we end up with x's that now look alike. Oops, I'm multiplying by 5, I'm sorry. That's 20, y is equal to 10. Okay, So now we look at this new problem, and we see that the x's would cancel each other out. Positive 10, negative 10. That's gone. And we're left with 26y is equal to 74. Is that right? 74? Okay. Now, usually they give you some type of trick. Let's see. Well, did I make a mistake here? I feel like maybe I did. 60. Oh, that's 68. I'm sorry. That's 68. I was wondering. 68, negative 10, 6, 68, 10, 10, 10, 5, 10, 5, 10. Okay. And this would be by 3. If I divide both sides by 26, y is equal to 3. Okay. If I solve for y, we have to go back and solve for x. Now you get to choose any equation. You want to use this one, or the original one. I'm going to always choose the original ones because the original ones are always smaller. And I'm going to choose a positive x. 2x plus 4y, we said y is now 3, equals to 2. We can then solve this pretty easily. Divide both sides by 2, x is negative 5. Okay, solving a system of by elimination, so same idea here, except this one's going to be easier. I just need to match either the x's or the y's, and it's up to you. Either one would actually give us the correct answer still. Can I do 3 again? Not really. I can jump back to 3 really quick, but I'm trying to do the whole thing. So 3, it's, you want to solve this for y to make it easy to graph. So 1 is already graphable. The second one, we want to change it to slope-intercept form to graph. And then once you graph it, you can see where they intersect. Of course, my lines are a little terrible. Kalia? So I'm going to change, it's up to you. You guys want me to match the x's or the y's? It's up to you. Anyone have a preference? If no one has a preference, I'm going to go ahead and change the x's to 2 here. So negative 2x minus y is equal to negative 14. I'm going to change the bottom to 2x plus 6y equals to 34. Right, I found that was a lot easier for me. Then we see the x's cancel out. We're at 5. Y is equal to 20. Divide both sides by 5. Y is equal to 4. Again, if I find y, I still haven't found x, we have to go back and solve for x. You can pick any equation you want. I'll choose the easy one, x plus 3y, which is, we said was 4, is equal to 17. X is equal to, sorry, that's going to be 7. Whoops. Y is 4, yep. Plus 12 equals to 17 minus 12 minus 12. X is equal to 5. If I want to double check, you can plug this in. Negative 2, 5 minus y, which is 4, is equal to negative 14. Is that going to be true? Yes, that's negative 10 minus 4 is equal to negative 14. The last one I made it pretty easy. If z is negative 1, okay, then I can plug it into my z here. Then we can find y, and then we can plug z and y to find x. So this idea, we're working backwards. So if I plug z in, it's going to be y minus 2 times negative 1, because z is negative 1, right? Z is negative 1 equals to 3. So y is equal to negative, oh, sorry, I keep saying y is equal to, it's too much algebra 1. Plus 2 is equal to 3, minus 2 minus 2. Y is equal to 1. And then we can plug it into here. X is equal to, darn it, I keep doing it. X is plus 9 times y, which is 1, plus 7 times z, which is negative 1, and make that equal to 3. So x is equal, x plus 9 minus 7 equals to 3. This becomes 2. Minus 2 to both sides. X is equal to 1. In this case, how many solutions do we have? And the answer is we actually have only one solution, because the solution is 1, 1, negative 1. 1, 1, negative 1. So these aren't three solutions. This is one solution. We had a situation where this could be infinitely many solutions or zero solutions. In Algebra 2, we'll almost never end up with a situation that's zero solutions. It will be like three planes that were sitting on top of each other, which we won't get. But infinitely many solutions is if two of these, for instance, were exactly the same equation, and they end up canceling out to be 0 equals to 0. Now this question here is going to take up a lot of your time. And but this one is written in a way that would actually be a little faster. So if I'm going to give you a solving a system with three equations, I'm not going to have you spend 10 minutes on it. This will be a 3-minute problem. And if you look here, one of these variables automatically are going to cancel out already. If we take a look at number 11, which of these variables are going to automatically cancel out? Do the x's cancel out? Do the y's cancel out? Or do the z's cancel out? Remember, I'm saying do these, or these cancel out by elimination. Okay, we're going to combine them. And the answer is, take a look, the answer is that the z's are going to automatically cancel out. Okay, the z's, these are going to do it. Sorry, not z's, I'm sorry, the y's. Sorry, I was trying to do three things at once. The y's are going to cancel out. So we're going to do that right here without a fuss. These two equations become negative x and negative 2x become negative 3x, because we're adding down. Positive y minus y becomes 0. And negative 5, negative 2 is negative 7z is equal to 12. 12 plus 0 is 12. Okay, we're going to be halfway there already. And then we're going to combine these two together. Well, the y's cancel out, right? That's our goal. So our x's is negative 2x plus 4x is positive 2x, right? 4 minus 2 is 2. We have no y's, and our z's is actually going to become 0. So I'm not going to write that. I guess I'll write that for now. Equals 6. Perfect. Now, look here. I can actually solve for x now. X is equal to 3. That's great. If x is equal to 3, we can now solve for z. 3 times 3 is 9, so negative 9 minus 7, z is equal to 12. I'm going to add 9 to both sides. Negative 7z is equal to 21. Divide by negative 7 to both sides. Z is equal to negative 3. Great, we have x, we have z, we still need to look for one more variable y. And use any of these options here. I'm going to choose the first one. Actually, you know what? I'm going to choose... Sure, I'll choose the first one. So if I plug in x is 3, so it becomes negative 3 plus 6y minus 5 times z is negative 3, so it's going to be positive 15 is equal to 12. Combine like terms, that becomes a 12. 6y plus 12 is equal to 12 minus 12 to both sides. 6y is equal to 0, so y is equal to 0. So our point x is 3, our y is 0, and our z is negative 3. Okay.
Hey, Mr. Cole.
Yes.
I'm a bit confused on for the second part. Where did you get 0 exactly?
Okay, good question. If you look at the z's here,
Yeah. Oh, they cancel.
They cancel out to become 0. That's why. Yeah.
Okay. So we weren't supposed to continue with canceling y?
We did cancel all our y's already. We canceled this y and we canceled this y. So y's were out of the equation. So by round 2,
so we're
y's
just
are
supposed
eliminated.
so we're just supposed to leave one variable?
In the end, the goal is to get one variable at the very end. But it comes in like 3 rounds. We first play one round to get rid of the y's. That's it. And then next round we were supposed to get rid of like the x's maybe. But we lucked out in this problem to save time. And they got rid of the z also for me in this problem.
Mr. Ko?
Yes?
Don't the two y's not cancel out because they're both negative?
Oh my goodness. What in the world? What did I do? I picked the wrong one. How come? How did I get there?
You're supposed to do the first and the third, right?
Yeah, the first and the third. I'm sorry. Thanks for... Alex, you caught me. You caught me, Alex.
Didn't you still get the correct answer, though?
I do not know why.
Okay.
I probably fudged it someplace in the back of my brain. Oh, I wish I could edit this, but I'm not going to edit it. So Alex is a genius, and he told me that I should have used these two instead. Those would have canceled out. These guys don't cancel out. Okay, so when I did that, oh my goodness, I'm such a klutz. So 4 minus 1 is 3x. And then negative 5 and positive 2 is negative 3, z. Okay, and this equal to 12 and 6 is 18. So the goal of this, if I do give you a system of 3 equations, it's going to be straightforward. Okay, it's not going to be super complicated. It's not going to take you that much time, like I just wasted. Now you can take a look. The z's, so the x's cancel out. Those are gone. So we're in the negative 10z equals to 30. So z is equal to negative 3 because I divided both sides by negative 10. All right, great. Now we know z. We can plot back into one of these equations here. I'm going to actually choose the second one, 3x minus, hey wait, what's negative 3 times negative 3? Right, that's negative 3. That's going to be positive 9 equals to 18. Minus 9 minus 9. 3x equals to 9. X must be 3. Okay, so we found z, we found x, and now we have to just go back and find y. And you can use any one you want. I'll use the fourth one, sure. I'll use the first one, dang it. Negative 3 plus 6y minus 5 times z. Z is negative 3, that's going to be plus 15 equals to 12. And these guys combine out to become positive 12. So 6y plus 12 is equal to 12 minus 12 minus 12. 6y is equal to 0. Y is equal to 0. Okay. Thanks for catching that, Alex. The goal is to cancel out the variable, not make up numbers yourself, like Mr. Ko. Okay, we got 17 more minutes to run through 17 problems, something like that. Okay, so one cool thing about this problem is that if you recognize it's a parabola, you can automatically graph the vertex. We said ax minus h squared plus k. That was my standard form, where h and k were my vertex. Now remember, there's a negative sign already there. So this is actually x minus negative 4. Okay, that's really what it is. So my h and k here would be negative 4 comma 5. So negative 4 comma 5, positive 5, we're up here. That's my vertex. Put a dot there. And the a value tells you how much we grow or shrink. In this case, we're going to do one step over, one step down. And that was a hint. That first step tells you how much we're going to grow or shrink. Now, what if this was a negative 2? If this was a negative 2, exactly the same thing. X minus, sorry, plus 4 squared plus 5. If that was negative 2, this negative 2 would be one step over, two steps down. This guy would be growing even faster down. What if this was positive 1/2 x plus 4 squared plus 5? Okay, sorry, I'm changing the colors. Okay, green. Same exact vertex, but we would be growing 1/2. See, this would be 1/2 right there. That's 1/2. So not one full step, we would be 1/2. So that's this hint. The hint is on the first step, that's our a value. Now, if you all are off by just a very little bit, because let's say you couldn't get it to be at that negative 1, that I would have given you credit for that. But if it's off by too much, then of course not. So one cool thing is that if we are able to graph vertex form, the vertex here is negative 4 comma 2. That's how fast we can see it with a value is negative 1. Negative 4 comma 2 is going to be up here. And the a value is negative 1. So one step over, a value tells me negative 1. So I'm going to go down by one step. Now again, make sure you do practice the review. Each of these different types of platforms, they graph a little differently, so you want to make sure you practice so you're not confused about how to draw that parabola. So you have to click parabola first, and then you can pick the vertex, and then pick the second point. This here is again another parabola with a vertex at 4 comma negative 2. So at 4 comma negative 2 is where we're going to be down here. I want to graph our graph one step over. A is 1, so we graph one step over. That's how fast it is. All right, this one seems a little tough. The quadratic function has its vertex at -7, and passes through point -4, comma, -3, right? When written in vertex form, the function has this form. So they want us to write out the a, h, and k version. So we worked with these problems. Given 2 points, how do I go back and write the parabola? Well, one cool thing is that I already gave you the h and k, right? That's my vertex is h and k. So if we fill out, we at least know a, x plus 7, because negative is positive 7, minus 7. We know that part. So we have to just find the a value. Now the trick is that I know an x value and I know a y value. So we know everything else but that a value. So -3 is equal to, what's 7 minus 4? That's going to be 3. 3 squared is 9. I'm going to just jump to that, because 7 minus 4 is 3, and we're going to square it. That's going to be 9. So that's going to be 9a, but that's we'll fix that later. So plus 7 plus 7. 4 is equal to 9a. Divide 9 to both sides. Sorry, 9. So a is equal to 4 over 9. Now, if you write 4 over 9, that's what I expect you guys to write. This decimal value is just the way the computer is reading it. But if you write 4 over 9, that would have been perfect for us. And it's one of our ways of writing the equation of a parabola. This one was a free throwaway. Vertex is h and k. Now, also just to remind you, all these questions I put specifically have videos to them, okay? So if you guys get stuck, you guys can also watch that video too. Find the equation of the graph below. Sure. Now, if you look at the vertex, easy peasy, our vertex is at -2, comma 2. Now, if you write down our standard form, x minus h squared plus k, sorry, not standard form, our vertex form. So we know our h is -2, and we know our y is 2 already. So we have x plus 2 squared plus 2, right? That's what we got. Now the a value is the hard part, but we had a trick. The a value is one step over. Did we go up or down? In this case, we went down by 1, 2, 3. I can tell you it's automatically -3. And that's the cool part about learning the parts of a graph. We can use those to graph a graph easily. Okay. Let's see if we can do the second one. Very similar to that. Very similar. My vertex is 2, comma 1, right? X's and Y's, and that's what we want, 2, comma 1. And then they want us to write the equation of it. A x minus h squared plus k. Sure, you can write this on your cheat sheet just so you don't forget it, but knowing how to use it is totally different. Now, also you have to show work, okay? This one you don't really have to show work, but on other questions you have to show work. So my h is x minus 2 squared plus 1. Now the a value is going to be tough. Let's take a look here. One step over, one step down. Ah, I see that's -1. And that's exactly what they wanted us to write. So again, make sure you practice on the platform so you don't waste all your time just trying to type it out. Okay, if you get pretty close and then you mess up on something dumb, since I'm looking at your work and your input values, if I can tell that, oh, it was just a typo mistake, I will give you back the credit, okay? But make sure the work is written in your notebook so I see it. Okay, this is the same thing as we did before. Our vertex is 1, comma 1, and the a value, one step over, one step down. See, a says -1. That's how fast I can read it. All right, we're on question 24 already. All right, we're almost there. I think we're going to make it. Now, this question is our absolute values, graphing absolute values. Now, if you look here, that was my h and k also. So my h is 2, my k is -7. And the a value is how fast I'm changing. But they asked us only write the answer in the order pair, find the coordinate of the vertex. The coordinate of the vertex is 2, -7. That's it. Easy peasy. Which leads us to our graphing part of this. Can I graph it? My x is -1. So my h and k is -1, comma 3. And my a value is -2. So let's graph the vertex first. this is a absolute value graph, so we're looking at our v graphs. -1, +3, we're up here. And the slope is, rise is -2 over 1. And we go the same way to both sides. That's how we end up with our v graph. Okay, let's go ahead and move on to our next question. 22. This was our, careful, it's ax minus h plus k. Now the h value is going to be 0 here. That's why it's just alone. So it's 0, 5. 0, 5. And it's going to be one step. A value is invisible 1. So one step over, one step up, one step over, one step up, one step over, one step up. Okay, we're almost there. Last couple questions is first, the equation is this and the focus. Remember, these are our tough questions. This and the focus. So if my vertex was, okay, so we can set up the easy part. X plus 5 squared plus 4, because that's my h and k. And since it's negative, become a positive. And then we are looking for our a value. Now the thing is we had a formula to get from the focus to the vertex, right? The focus is the vertex, not the directrix. So let's draw this out real quick. If my vertex is at -5, 4, and the focus is up here at -5, 8, right? What is the p-value we said? The distance between it is 4. So p is equal to 1 over 4a. Do you guys remember that equation? P is equal to 1 over 4a. So if p is 4, 1 over 4a, we do a flip. So it's a is equal to 1 over 4 times 4, which is 1 over 16. 1 over 16 x plus 5 squared plus 4. That is, just watch the replay. That's it. We use this magic formula to relate our p. It's the distance from the focus, not the directrix. It's the distance from the focus. And then we just write this equation here. Okay. Next one is passing through. Wait, the last one is just writing a point again with the vertex and a point. So if we have y is equal to a, x minus 1 squared plus 3. We need to look for a, but they gave us our x and y. They gave us our x and our y. How nice. That's sweet of them. -1 squared is 1, so just a plus 3. And minus 3 to both sides. A is equal to -1. And that's how we end up with our a, h, and k.